And we've built James Webb to be a observatory level facility rather than a sort of one-off mission. The Hubble Space Telescope, we've been able to look back to the order of about a billion years after the was taking all these beautiful pictures of these big dark dust clouds. What we want to do with Webb is actually peer inside these stellar nurseries and actually study stars as they're being formed and follow how they're born and then how they evolve.
Imagine a world bathed in the faint red light of a distant sun, a world locked in a perpetual dawn, orbiting a star just a fraction as luminous as our own. 40 light-years away, in the constellation Aquarius, a remarkable planetary system orbits a cool red dwarf star known as TRAPPIST-1. Of its 7 known planets, TRAPPIST-1d has long captured the imagination of astronomers and dreamers alike. Could this rocky planet, similar in size and mass to our own Earth, harbor conditions suitable for life? With the launch of the James Webb Space Telescope, humanity gained a new set of eyes powerful enough to peer across vast interstellar distances, to decode the faintest signals hidden in the starlight filtering through alien atmospheres. Webb's near-infrared spectrograph, or NER-SPEC, is designed for precisely this task, capable of dissecting the light from distant worlds to reveal the chemical signatures of their gaseous envelopes. Recently, the James Webb Space Telescope turned its gaze toward TRAPPIST-1d, hoping to answer a question as old as astronomy itself. Does this planet possess an atmosphere like Earth's? Does it have the vital gases, water vapor, methane, carbon dioxide, that could hint at habitability or even life? The results published in the Astrophysical Journal delivered a surprise. Webb's sensitive instruments found no sign of an Earth-like atmosphere on TRAPPIST-1d, not a whisper of water vapor, not a trace of methane, not a hint of carbon dioxide. For the first time, science can decisively rule out the presence of a thick, terrestrial atmosphere on this rocky world. At this point, said lead author Caroline Piole-Gorayeb, we can rule out TRAPPIST-1d from a list of potential Earth twins or cousins. The data are clear. Whatever air may once have hugged this planet's surface, it has vanished or perhaps never existed at all. TRAPPIST-1d's story is shaped by its environment. Orbiting at just 2% of the distance between Earth and our Sun, it sits on the inner edge of its star's so-called temperate, or Goldilocks, zone, where liquid water just might, be possible. Every 4 days, TRAPPIST-1d completes a dizzying lap around its host star, drawing it into an intimate gravitational embrace with its Sun. But this relationship comes at a cost. Red dwarf stars, though cool and dim compared to our Sun, are prone to violent outbursts, frequent high-energy flares that can strip away planetary atmospheres in spectacular fashion. The closer a planet orbits to such a star, the more vulnerable it is to these cosmic tempests. Over millions of years, these relentless flares may have blasted away any protective shroud of gas that TRAPPIST-1d once possessed, leaving behind a bare, airless rock. Yet the story may not be so simple. The absence of atmospheric signals leaves room for intriguing possibilities. Perhaps TRAPPIST-1d has an extremely thin atmosphere, like Mars, too insubstantial for Webb to detect. Or maybe it's shrouded in dense clouds, similar to Venus, masking its composition from our instruments. There is also the stark possibility that this world is truly airless, its surface exposed to the harsh vacuum of space. Understanding why some planets keep their atmospheres while others lose them is at the heart of exoplanet science. Red dwarfs are the most common stars in the Milky Way, and the planets that orbit them are prime targets in the search for life beyond our solar system. As co-author Bjorn Benneke explains, scientists are only beginning to define the boundary between worlds that can hold on to an atmosphere and those that cannot. The Webb telescope's ongoing survey of the TRAPPIST-1 system is far from over. Observations of other planets in the family, TRAPPIST-1, E, F, G, and H, are underway. These worlds orbit farther from their star, where the effects of stellar flares may be less severe, and the odds of retaining an atmosphere could be higher, though their colder temperatures make atmospheric detection more challenging. All hope is not lost for atmospheres around the TRAPPIST-1 planets, says Piolet Gorayeb. Each planet in this tightly packed system offers a new experiment in planetary evolution, a unique laboratory where nature reveals the interplay between starlight, gravity, magnetism, and the delicate balance of atmospheric gases. The stakes are profound. As NASA's Sean Domagal-Goldman points out, understanding which planets retain their atmospheres and why is one of the most important avenues in the search for life outside our solar system. Each new discovery, each new measurement from Webb, lays the groundwork for future missions, like the upcoming Habitable Worlds Observatory, that will probe ever deeper into the cosmos, searching for the telltale signs of habitable environments and perhaps life itself. The cosmic quest continues as humanity's newest astronomical sentinel, the James Webb Space Telescope, extends our reach to worlds never before explored. The TRAPPIST-1 system stands as a tantalizing frontier, a place where the mysteries of planetary atmospheres, the scars of stellar fury, and the hope for life beyond Earth converge in a single, distant star's embrace. With the James Webb Space Telescope's powerful gaze, astronomers have now peered into the depths of the TRAPPIST-1 system, unlocking secrets hidden in the faint starlight of a red dwarf 40 light-years away. At the center of this new revelation stands TRAPPIST-1d, a rocky exoplanet once thought to be a promising candidate in the search for Earth-like worlds. Its orbit, just 2% of the Earth-Sun distance, places it on the inner edge of the system's temperate zone, a region often called the Goldilocks zone, where temperatures could, in theory, support liquid water. But as Webb trained its near-infrared spectrograph, or NIR spec, on this distant world, a new story began to emerge. Scientists searched for the spectral fingerprints of an atmosphere, those subtle clues imprinted on starlight as it passes through any gases surrounding the planet. If TRAPPIST-1d were cloaked in water vapor, methane, or carbon dioxide, Webb's instruments would reveal their presence in the planet's delicate silhouette during a transit. Yet, after painstaking analysis, the results were clear. No signs of these common terrestrial gases could be found. The spectral data remained stubbornly flat, lacking the dips and peaks that would signal an atmosphere like Earth's. For Caroline Piolet-Gorayeb, lead author of the new study, this meant crossing TRAPPIST-1d off the list of potential Earth twins, at least for now. This outcome, while sobering, is itself a triumph of modern astronomy. For decades, the existence of rocky planets in the habitable zones of other stars was pure speculation, an abstract dream. Today, we can not only detect these exoplanets, but probe their atmospheres, or, as in this case, their apparent absence. Webb's findings suggest that TRAPPIST-1d is, in all likelihood, a world very different from our own. But what does this really mean for TRAPPIST-1d? Several scenarios remain possible. The planet could possess a whisper-thin atmosphere, as insubstantial as that of Mars, offering little protection or comfort for life as we know it. Alternatively, TRAPPIST-1d might be shrouded in dense, reflective clouds, like Venus, concealing its lower layers from Webb's sight. Or perhaps it is a bare, airless rock, its skies long since stripped away. The culprit behind this atmospheric vanishing act is likely the star itself. Red dwarfs, though cool and dim compared to our sun, are prone to violent outbursts. They emit powerful flares of ultraviolet and X-ray radiation, especially during their youth. Planets orbiting close by, like TRAPPIST-1d, are bombarded by these flares. Over millions of years, these high-energy blasts can erode and even obliterate planetary atmospheres, leaving behind only barren surfaces. This process, known as atmospheric stripping, is a cosmic reminder of just how delicate a habitable environment can be. The ability of a planet to hold on to its air depends on a delicate balance between gravity and stellar fury, a balance that TRAPPIST-1 may not have maintained. It's a sobering reality, but also a crucial clue as we refine our understanding of where life might take hold beyond Earth. Still, the story of TRAPPIST-1 is far from the end of the tale. The system is home to 7 known rocky worlds, each with its own orbit, temperature, and potential for atmosphere. Webb's investigation is just beginning. The focus now shifts outward to planets E, F, G, and H, siblings to TRAPPIST-1, but farther from the star, where the stellar wind is weaker and the chances of atmospheric survival improve. Yet these more distant worlds present their own challenges. Their colder temperatures mean that any atmospheres they possess are harder to detect as molecular signatures become fainter and more elusive. Still, the search presses on. Each planet observed, each spectrum analyzed, adds a vital piece to the cosmic puzzle. Why does this matter so much? Because red dwarfs like TRAPPIST-1 are the most numerous stars in our galaxy. If their inner planets are routinely stripped of air, it reshapes our expectations for habitable worlds across the Milky Way. But if some can defy the odds, clinging to their atmospheres despite the storms, then the universe may be richer in life-friendly environments than we ever imagined. NASA's Sean Domagal-Goldman sums up the stakes. The quest to understand which planets can retain their atmospheres and why is one of the most important frontiers in exoplanet science. Every observation with the James Webb Space Telescope, every spectrum from a distant world, helps to chart this unknown territory. And even as Webb pioneers these discoveries, it is laying the foundation for the missions yet to come. The data gathered today will shape the targets and techniques of tomorrow's telescopes, like the planned Habitable Worlds Observatory, which will take the search for life to new heights, perhaps even capturing the first direct image of a truly Earth-like exoplanet. For now, the TRAPPIST-1 system remains a symbol of both the promise and the challenge of cosmic exploration. With each new finding, we are reminded that our place in the universe is both rare and precious, shaped by forces vast and ancient. Yet the search continues, driven by the same curiosity that first led us to look up at the stars and wonder what worlds might lie beyond. The James Webb Space Telescope's investigation of TRAPPIST-1 marks a pivotal step in our search for habitable worlds. By focusing its powerful near-infrared spectrograph on this rocky planet, just 40 light-years away, Webb has delivered a decisive result. No detectable signs of an Earth-like atmosphere. The absence of water vapor, methane, or carbon dioxide in the planet's spectrum means that TRAPPIST-1 almost certainly lacks the shield of gases that make our own world so uniquely suited for life as we know it. This finding, while sobering, is a crucial milestone. It narrows our search, sharpening the focus on what makes a planet truly Earth-like and refining our methods for detecting the subtle fingerprints of alien atmospheres. The data also offer a fascinating glimpse into the harsh realities faced by planets orbiting red dwarf stars. These stars, cool yet volatile, frequently unleash high-energy flares that can strip away planetary atmospheres, especially from worlds like TRAPPIST-1 that orbit close in. What remains could be a bare, airless rock, a thin, tenuous veil of gas like Mars, or a dense, cloud-enshrouded world reminiscent of Venus, its secrets hidden from even our most sensitive instruments. But the story doesn't end here. The TRAPPIST-1 system is a cosmic laboratory with 7 rocky planets dancing around their diminutive sun. If TRAPPIST-1 is inhospitable, what about its siblings, planets E, F, G, and H? These worlds orbit farther from the star, where the relentless assault of stellar radiation may be less severe and the chances of atmosphere retention rise. Webb is already turning its gaze toward these more distant planets, searching for spectral clues that could signal the presence of thick atmospheres, clouds, or even the chemical imprints of life-friendly environments. Each observation builds a larger picture, helping astronomers decode the intricate balance between a planet's distance from its star, the fury of stellar activity, and the tenacity of planetary atmospheres. This knowledge is vital because red dwarfs outnumber all other types of stars in our galaxy. The lessons learned here could apply to billions of planets scattered across the Milky Way, dramatically expanding or narrowing the field of worlds that might harbor life. These discoveries also lay the foundation for the next generation of exploration. The James Webb Space Telescope is just the beginning. Missions like the upcoming Habitable Worlds Observatory will push even further, with technology designed to directly image exoplanets and analyze their atmospheres in unprecedented detail. Webb's results guide these future efforts, teaching us where to look and what signatures to seek as we hunt for truly Earth-like planets. Though we have ruled out TRAPPIST-1d as an Earth twin, the pursuit continues with undiminished vigor. Each null result is not a defeat, but a signpost guiding us through the cosmic wilderness, revealing which worlds are barren and which may yet surprise us. The search for life beyond the solar system is a quest defined by patience, precision, and the relentless refinement of our scientific tools. Every new observation, every carefully analyzed spectrum, brings us closer to answering one of humanity's oldest questions. Are we alone? Imagine, for a moment, the significance of detecting a distant world with a thick, oxygen-rich atmosphere, or the unmistakable chemical traces of biological activity. The technology now at our disposal and the discoveries just beginning to emerge make this prospect more tangible than ever before. As astronomers probe the TRAPPIST-1 system and countless others, each discovery, expected or not, unfolds new chapters in our understanding of the cosmos. The universe is vast and mysterious, yet step by step, we are peeling back its layers. The journey from wondering about distant suns to directly probing their planets' atmospheres is a testament to human ingenuity and our enduring sense of wonder. TRAPPIST-1d may not be another Earth, but it is a vital piece of the puzzle, a reminder that the search for life is as much about narrowing possibilities as it is about finding new worlds. As Webb and its successors scan the skies, the excitement grows. What will we find on TRAPPIST-1e or F? Will the next breakthrough come from a planet we've never even imagined? The only way to know is to keep searching, to keep building better instruments, and to keep asking bold questions. If you're as fascinated by these cosmic discoveries as we are, make sure to like this video and subscribe for more content like this. There's an entire universe out there, and together, we'll continue to explore its wonders.